It's a clear night, and you're outside looking at the stars. The Milky Way alone seems overwhelmingly huge. You check on your phone and discover that the galaxy you're in at this exact moment is 100,000 light years wide. For scale, 1 light year is already a very long distance. For example, it takes 4.2 light years to go from Earth to Proxima Centauri, which is the closest star to our planet other than the Sun. So, 100,000 light years is way more than we normal humans can fathom. And that's just one galaxy. There's a whole lot more out there. Now, looking at this data, it seems pretty unlikely that we're the only life form out there, doesn't it? But how come we've never found anything else so far? Let's get one thing out of the way. Extraterrestrial life doesn't necessarily mean we're talking about little green people. It can also mean microorganisms, bacteria, and plants that can be found on other planets. The truth is, there's a big spectrum of possibilities for life on another planet. And taking into consideration that there are up to 50 billion planets in the Milky Way, it's very unlikely that we're alone in this big wide universe. And what does life on other planets look like? This is what we've spent years trying to figure out. Go ahead, think with me. A planet may be lifeless today, but it could have traces of organic matter or fossils, meaning that some life form was able to thrive there once. And it could also be that there are planets out there containing life with complex biochemistry, meaning they could have fauna just like we have on Earth, although probably not the same. NASA created a special science that is dedicated to studying life forms outside of Earth. It's called astrobiology. Ever since the space agency was created back in 1958, it didn't take long for it to start looking for extraterrestrial life. They quickly built an action plan. First, they needed to understand how life on Earth was formed, and secondly, how it could have formed on other planets. The first time NASA tried to look for life in outer space was in 1976. The Viking lander blasted into space, headed towards Mars. There were high expectations that humanity would find the first proof of extraterrestrial life. Unfortunately, the lander came back with images of a planet that looked barren and bleak, and scientists were extremely disappointed. Scientific conclusions on whether life could be detected over there were confusing. But hey, you need to know what you're looking for to find it, right? The failure of the Viking mission served to heat up debates amongst NASA scientists to define what life actually meant. And it also served to call their attention to a small but very important detail. Spacecrafts departing from Earth usually transport Earthling microorganisms and bacteria unintentionally, as they remain attached to the vehicle. It turned out that these bacteria could contaminate scientists' samples, so they needed to consider this. All of this made Mars expeditions take a back burner on NASA's short-term plans. There appeared a new priority-first question. What are the types and stages of life that space programs can hope to identify? Scientists might have encountered life on other planets, but they weren't able to identify it as life. That is why NASA began to study our own planet better. They studied everything from ancient life forms that lived billions of years ago to living creatures that roam the planet today. They understood that the search needed to happen inwards as well as outwards. Let's take a look at the development of Earth's life from its inception. Imagine that this development can be represented as a ladder, or stairs, and each developmental stage is a flight of the bigger staircase. First, we would see basic chemistry, a soup of loose chemical elements like the ones we see in the periodic table. But they need to assemble themselves into more complex structures to be able to self-replicate, change, and evolve. This would happen in the second step, where we start to see the formation of microscopic organisms. In the third step, these cells combine to become multicellular beings, allowing for more complexity and variety. The step above sees species that can evolve big brains, enabling the use of tools, culture, and shared knowledge. That's where humanity is located. Looking at this ladder, one might ask, So, what does it take for a multicellular organism to evolve into fully formed humans? This is what is called the Great Filter. It's a huge evolutionary jump that takes a lot of effort and the perfect environmental conditions for it to happen. And given that we haven't heard of any other extraterrestrial civilizations out there, it might be that we're the only ones that were able to make this jump. After all, how likely is it that we'll find life outside of Earth that is similar to us? That depends on how many planets there are out there in their star's Goldilocks zone, the area around a star where water can be liquid. And because stars come in all sizes and configurations, this zone is different for every star system. But that's not the only criteria we know for the existence of life. We usually look for three things to detect life: liquid water, methane, and oxygen. Water is what allows for chemical components to mingle and connect, forming multicellular beings. Methane is produced by the decomposition process made by bacteria, and oxygen is the byproduct of plant respiration. These are some of the telltale signs that the James Webb Telescope was programmed to search for. The James Webb Telescope has ambitious purposes that might revolutionize space science. Its top priorities are to detect forms of life by studying small galaxies orbiting the Milky Way. It will also look for the oldest stars in the universe, trying to gather data on the origin of the universe itself. That's huge! NASA is betting on two variables with this new telescope: a thorough scan on the so-called exoplanets, aka planets from outside our solar system, and the search for extremophiles, a type of life that loves extreme environments. Extremophiles were first discovered on planet Earth back in the 1960s at the bottom of the sea near the Galapagos Islands. Scientists found microorganisms living next to hydrothermal vents that dot the sea floor over that part of the world. Thriving in places like these with extreme temperatures over 700 degrees Fahrenheit takes a lot of resistance. I mean, can you imagine the heat? This discovery was a turning point for the field of astrobiology, as scientists understood that life could survive in extremely harsh conditions, similar to the atmosphere available in several exoplanets. But hey, life might turn up in our own neighborhood if we're lucky enough. Guided by the mantra, "Follow the water," NASA is launching two important missions inside our solar system that can contribute largely to the search for extraterrestrial life. You remember Jupiter, right? It's the gas giant that has a moon known as Europa. A few years ago, scientists discovered that Europa had an ocean hidden behind layers of icy crust. And there's even more. According to research, the water over in Europa is salty, much like the water we have on our planet. Europa is a big contender for the detection of life. But the Europa Clipper mission is not aimed at trying to identify this. Rather, it will orbit the moon and gather as much information about its atmospheric conditions as it can. The other moon-bound mission is the Dragonfly, an octocopter that will explore Saturn's moon, Titan. The launch is programmed for 2027 and will only arrive in Titan's orbit around 2034. It will sample and examine a series of promising sites around Saturn's icy moon. And who knows, find some new information on ET life? Let's see what happens. But I'd say we've never been closer to a huge discovery than we are now.
We've been dreaming about life on Mars for a long time. Not only about growing potatoes there in the future, but also about all the potatoes that could have been there in the past. Has there ever been life on Mars? Recently, scientists have found something that could be evidence of that. Let's find out what happened. Mars is the fourth planet from the Sun. A human hasn't set foot on Mars yet, but robots have set their wheels. The first spacecraft that visited the Red Planet were NASA Viking landers. They flew there back in 1976 and sent us a lot of interesting data. Back then, we didn't know anything about Mars. To us, it looked like a cold, lifeless desert. But since we're so similar, scientists began to wonder, has it always been like this? Or is it possible that once Mars used to be thriving and full of life? And in 2022, NASA's Mars rover Perseverance found something that could shed a light on this mystery. But first of all, what is Perseverance? Scientists have suggested that if there was life on Mars once, it's unlikely that it could simply disappear without a trace. It must have left some traces, perhaps underground, where they would be protected from radioactive solar tantrums and other nastiness. So we need to check the rocks. It's important to note that we aren't looking for life on Mars right now. There most likely isn't any. Instead, we want to look into the distant past of our twin planet. We're talking billions of years ago, when Mars could have been warm, green, and far from lifeless. In other words, we have to find dead microbes and various chemical compounds similar to ones on the Earth. This is the mission of our main character, Perseverance. It arrived on Mars in February of 2021. The spacecraft landed on the bottom of the 30-mile-wide Jezero crater, and after landing, it scooted over to the west, to the place that prompted scientists to choose Jezero for research. This place is a dried-up river delta, and this former river is already more than 3.5 billion years old. The Jezero crater itself was once a large lake. Yup, apparently there was life on Mars, and scientists have suggested that these places would be perfect as bodyguards of microbes. That's exactly what bacteria do on Earth. They hide, being still in the depths of lakes and ponds, so we could probably find traces there. The researchers believe that this particular lake has the highest scientific value in the entire mission. The highest chance to find rocks on which such bacteria could survive is here in Jezero. So Perseverance went to the delta. The row wasn't easy though. The rover missed a little and landed further than planned. As one famous movie said, "This little maneuver's going to cost us 51 years." Fortunately, Perseverance took only 1 year, and on the way, it was able to explore Jezero a little. The rover uses a complex built-in tool to explore the world. The tool is called Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or just SHERLOC. Boy, NASA sure loves its acronyms. As the device approached the delta, the signal of organic molecules became stronger. Soon, these signals were everywhere, and besides, they were the brightest that the scientists have ever seen. What does it mean? Elementary, my dear Watson. You know, Sherlock. It's time to dig. Since July 2021, Perseverance has drilled and collected 4 thin cores of sedimentary rock. The total number of collected rocks at the moment is 12. This is the first time in history that we're collecting something like this on another planet. These 4 cores were found on 2 rocks called Skinner Ridge and Wildcat Ridge. The first pair of cores, the ones from the Skinner Ridge, don't seem very interesting at first glance. They're quite close to what we can find in many places on Earth. However, if we look at them closer, we'll see that they're dotted with round grains of some dark material. These dark grains could have once been deposited on them by an ancient river, the same one that flowed into Jezero. It's possible that the river brought them from places hundreds of miles away from Jezero. And that's pretty cool. If we study these cores, we'll be able to learn even more about the far corners of Mars. Well, there are no corners on it, but you get the idea. Then, in April 2022, Perseverance did arrive at the delta, and then scientists finally found what they were looking for. The discovery, to put it mildly, excited them. They found 2 more cores, which held organic substances. This pair was taken from the Wildcat Ridge. It's found very close to the Skinner Ridge, but the 2 rocks are quite different from each other. These samples are lighter in color and more uniform. Most likely, they're mudstone, an unusual rock similar to clay, but harder and unable to absorb water. They're also finer grained than the cores of the Skinner Ridge. Why does it matter? Because the finer the grains in the stone, the more likely it is that there may be some traces of a past life in it. On Earth, fine-grained stones most often lie on the bottoms of ponds and in similar places. There, they can preserve the remains of dead organisms and similar stuff for years. And this is exactly what we found on them. Additionally, according to scientists, There was more organic matter in these two cores than in any other place studied by Perseverance so far. It probably accumulated there while the lake was gradually evaporating billions of years ago. So, there really was life on Mars? Well, let's slow down a little. Organic substances are molecules holding carbon. And yes, on Earth, they're most often associated with life, but not always. Sometimes they can form as a result of other things. Therefore, we cannot say for sure whether there was life on Mars. We don't know if these molecules really remain from some Martian microbes, or if they're the result of some other things. But the discovery is still very significant. We have to literally keep digging this way. To learn more about this organic matter, scientists need to collect a couple more samples of fine-grained rock. It would also be great to study the material lying around these former reservoirs. Perseverance has already moved to another area, to a place with a beautiful name, Enchanted Lake. Now it needs to look for similar things there. It will also continue to study Lake Jezero. Eventually, Perseverance will climb to the top of the delta and then continue exploring ancient sites outside the crater. Sometime before the end of 2022, Perseverance will probably have 6 or more samples of the Martian cores. Unfortunately, its tools, though complex, are quite limited. This data alone won't be enough for us to get a complete picture. Therefore, NASA plans to send other spacecraft to Jezero in the coming years. Together with the European Space Agency, they're working on the next robotic mission, known as the Mars Sample Return. The name speaks for itself. These devices will arrive and take away all the test tubes from the old Prospector Perseverance. After that, these samples will be delivered to Earth, though not by Amazon Prime, and then scientists will be able to analyze them in advanced laboratories. However, all this will take a really long time. The launch of this mission is scheduled for 2027-2028, and the spacecrafts won't be able to return until 2033. But if everything goes well, it will be the first samples in history delivered to Earth from Mars. In other words, there's still enough space for research, literally. And yes, we don't yet know the true meaning of these finds. But that's why the entire mission was created, right? And who knows? Maybe in a few years we'll finally find out the truth about what happened on Mars billions of years ago. Ooh, check out The Martian! Made you look.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa, and scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet, and it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas, and where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
Venus has more volcanoes than any other planet in the solar system, more than 1,600. And a day on Venus, measured by how long it takes to rotate once on its axis, takes longer than the time it takes to complete a full orbit of the Sun. Wow! And that's just Monday. An extreme greenhouse effect warms the planet's surface up to 870 degrees Fahrenheit, hot enough to melt lead. Winds there reach the speed of 450 miles per hour in the middle cloud layer, faster than the speediest tornadoes on our planet. The pressure on Venus's surface is 90 times higher than that at sea level on Earth. What a great place for a vacation, huh? And recently, this incredible place has become even more intriguing. In the toxic Venusian atmosphere, there's something that might mean the existence of life. Unfortunately, scientists haven't had a chance to collect any microbe specimens or snap any pictures of life there. But they've discovered a chemical called phosphine, and it's a big deal. If it's not some previously unknown chemistry that produces the gas, then there must be a kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any normal life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. The weirdest thing is that phosphine isn't supposed to be in Venus's atmosphere at all. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, the famous gas giants, but on Venus, totally unexpected. There's no way phosphine can be produced naturally on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere. But it's not nearly enough to explain what the astronomers have observed. It would only make 1/10,000th of the phosphine the telescope saw. But let's start from the very beginning. In 2017, a group of scientists led by Jane Greaves from Cardiff University started to use the James Clerk Maxwell Radio Telescope in Hawaii. That's a mouthful. The main idea was to search for phosphine gas. It would be a sign of life on Venus. When the data came back and the researchers analyzed it, they were shocked. The phosphine signal was powerful. The team checked the results several times. They wanted to make sure no other substance mimicked the presence of phosphine gas. So now, does it mean there's life on Venus? Well, not necessarily. If this gas is created by some mysterious organisms, it's a big question how they survive on Venus. On our planet, some microbes can thrive in the environments with the acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid. And even though they have a rather pleasant temperature of 86 degrees Fahrenheit, these clouds contain more than 90% of sulfuric acid. DNA, amino acids, proteins, life components on Earth would be dissolved there in the blink of an eye. The surface of the planet is too hot for any kind of complex molecules to make up life. The Venusian atmosphere is almost 50 times as dry as the driest place on our home planet. There's a theory that microbes might hide in scarce water droplets floating in the atmosphere, but it hasn't been proved yet. Right now, the research team's waiting for more telescope time. They're going to look for other gases associated with life. But even if they find more evidence, life forms on Venus will be made up of building blocks absolutely different than those on Earth. Or they might be protected by a sulfuric acid-resistant shell. It can be made of such substances as sulfur, wax, graphite, or something else we can't imagine. Of course, some experts question the idea of life on Venus. They think the gas might be produced during some geologic or atmospheric processes happening on the planet. But the supporters of both theories agree on one thing: the discovery is extraordinary. Interestingly, astronomers have always tried to find signs of life on giant planets' icy moons, or even closer, on Mars. But they've never seriously considered Venus. If additional telescope observations and future space missions confirm that phosphine is produced by living organisms, we can be in for a bunch of exciting surprises. Then people would know of a planet with an alien biosphere, well, alien to us, and this planet would be just next door to Earth. Now, speaking of visiting Venus, though, would it be possible for people to land on this planet? After all, robots are already tooling around the red planet surface. On the pro side, Venus is closer to Earth than Mars, but it also has much harsher conditions. The planet is hotter than Mercury, even though Venus is almost double the distance from the Sun. The temperatures are higher than the melting point of many metals, and some of them, like lead or bismuth, can fall as snow on the highest mountain peaks. If you set foot on the planet, you'll find nothing but barren rock. Giant basaltic plains are littered with volcanoes and mountains. In some places, the surface melts because of the heat underneath. After it releases some of it, the rock solidifies again. If people ever go to this planet, they will most likely build floating cities in the clouds of Venus's atmosphere. At about 31 miles above the surface, the conditions, like the pressure and gravity, are similar to those on Earth. The temperature is rather manageable too, at around 167 degrees Fahrenheit. Think Death Valley, California on a really hot day. The atmospheric pressure is half of what we have at sea level on our planet. If you went outside, you'd be fine without a pressure suit. The pressure you'd feel would be the same as at the top of Mount Kilimanjaro. Plus, this colony would be protected from the sun's radiation better than one on Mars. If the atmosphere was the mission's final destination, landing a spacecraft, or rather making it hover in the air, would look very different. The idea is to use an airship in the upper atmosphere for long periods of time. The airship, wrapped in an aeroshell, would enter the planet's atmosphere at a speed of 24,000 feet per second. In the next 7 minutes, its speed would drop to around 1,500 feet per second. After that, a huge parachute would open. It would slow the spacecraft down even more, and then things would get a bit hectic. The aeroshell, not needed anymore, would drop away. The airship would then inflate itself, all the while hurtling through the atmosphere toward the planet's surface. Its speed would be at least 330 feet per second. It would get larger and larger, and its drag and lift would increase. Soon, the parachute wouldn't be needed anymore. The crew would get rid of it, and the airship would fill with air completely. If everything went as planned, it would stop 30 miles above Venus's surface. After that, the airship would travel around the planet. It would be moved by the wind, which can reach a speed of 220 miles per hour at the top of the cloud layer. If you decided to move closer to the surface, though, you'd have to be extremely careful. The wind in the middle layer can get twice faster. The airship could be filled with a breathable mixture of hydrogen and oxygen gases. Such a combination would be less dense than the Venusian atmosphere. It would provide the needed buoyancy, to stay up there. Venus is famous for its super dense clouds. These clouds make the planet shine bright enough to be seen from Earth. Venus reflects more than 75% of the light that comes from the Sun. This reflective cloud layer exists thanks to a haze of sulfuric acid droplets in the atmosphere, and they gather exactly at the height where the airship would float. Luckily, people already have a method to overcome the problem of acidity. A few materials, for example Teflon and some types of plastic, have an amazing acidic resistance. They could protect the outsides of the ship. So, let's say you needed to work on a platform outside. Then you'd be able to do it, wearing only a chemical hazard suit and carrying necessary oxygen supply. Ooh, sounds like fun, huh? Yeah, me neither. Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June, 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers used different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler-22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth. It's about 2.4 times our planet's size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler-22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler-69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.
Mars is the Earth's space cousin. It's the 4th planet in our solar system, about half the size of the Earth. It also has 2 small moon buddies, Phobos and Deimos. These moons are shaped like potatoes. Phobos is the drama king, moving closer to Mars and planning a crash landing in about 50 million years. Deimos is much calmer though, hanging out farther away from Mars. Mars got a cool nickname, the Red Planet, thanks to its rusty red surface. This color was so bright that it was spotted by astronomers many years ago. Even you can sometimes see it in the sky with the naked eye, a small scarlet dot. And maybe it has hot vibes, but in reality, Mars is a very cold desert. The temperatures there can drop as low as minus 240 degrees Fahrenheit. But was Mars always nothing more than a rusty-looking desert? Actually, no. Scientists believe that perhaps many years ago, this planet was similar to ours. Meet Curiosity, the detective rover made by NASA's Jet Propulsion Laboratory. Scientists want to know all about the Martian weather, landscape, and other stuff like that. Curiosity is a pretty heavy car-sized robot. It weighs about 1,985 pounds. It embarked on its journey on November 26, 2011. The rover pulled off a landing on Mars on August 6, 2012. Originally, Curiosity's mission was supposed to last for 2 years, but it's still going strong. Curiosity is basically a space lab on wheels. It's packed with cameras, spectrometers, radiation detectors, and sensors to sniff out the Martian environment. As Curiosity roams around, it rewinds Mars history. And during its mission, the rover discovered something incredible: signs of lakes and rivers from long ago. You see, Curiosity's favorite spot to play around is Gale Crater. It's a prehistoric Martian oasis where water might have hung out. There's this huge mountain in the middle called Mount Sharp. This place is taller than 10 Eiffel Towers stacked on top of each other. And it's got layers of rocks that hold Mars's ancient secrets. Recently, scientists spotted something great when studying Curiosity's data: mud tracks. What's so surprising about that? Well, these aren't just any old tracks. They're like messages from the past. They mean that the Martian ground used to get wet and then dry out again. The mud on the ground would shrink and crack during the drying phases, making these T-shaped junctions. Moreover, it seems like the ground on Mars went through several wet-dry cycles. It happened maybe up to 10 times. This made the junctions turn into Y-shaped cracks. When a bunch of Y-shaped cracks got together, they made a super cool pattern, something like a patchwork of hexagons. It looked just like honeycombs, or even a dragon's skin. Each of these hexagons are the size of candy. Similar cycles have happened on Earth, and they're linked to the birth of life. When water dries up, it leaves behind concentrated stuff that's great for chemical reactions, and these reactions might be the same ones that kickstart life. These hexagons have been hanging around for a really, really long time, billions of years. That means that Mars once had a climate kind of like Earth's, and maybe even life. In fact, the red planet even has some signs of water right now, in the form of hidden ice at the poles. Mars has the North and South poles, and just like with the Earth, they're red planet's ice caps. Picture the North Cap as a big, icy pancake about 620 miles wide. The South Cap is a bit smaller, about 220 miles wide, but it's got a thicker ice layer, almost like a snowball with a strong shell. When it's winter at the poles, it's an incredibly long nighttime. No sunlight, just chilly darkness. During that time, around 30% of the air turns into frozen CO2. It's dry ice, the same stuff that's often used in horror movies. But when the poles wake up to sunlight, the dry ice turns back into gas. All this freezing and thawing makes clouds and frost, just like on Earth. One time, a rover named Opportunity even caught some clouds made of water ice. But it doesn't necessarily mean Mars was once thriving just like the Earth. Life needs more than just wet, dry cycles to pop up. It needs the right atmosphere and other special ingredients. We're not sure if Mars had all of those, and even if it did, there's no guarantee that life actually happened. But this raises another very important question. Has Mars ever hosted tiny living creatures? Curiosity isn't the only robot that tries to find the answer to that. There's also a rover called Perseverance. It's trying to find clues about Martian life. It's digging into an old Martian crater once filled with water. And like a space archaeologist, Perseverance is searching for fossilized signs of ancient critters. And here's the funny thing. Some scientists think that we've stumbled upon it almost half a century ago. The only problem is, we might have accidentally destroyed it. It happened even before Curiosity started rolling around Mars. Back in the 1980s, two cool NASA's landers, Viking 1 and Viking 2, made a pit stop on the Red Planet. These landers took a selfie, and then they also did some funky experiments on the Martian soil, all in the name of finding signs of life. What they found is some weird organic stuff called perchlorate. It's a compound that we use in fireworks or rocket fuel. But most results didn't seem that promising. They even mixed up some soil with water and nutrients, hoping that if there were Martian microbes, they'd snack on the goodies and return radioactive gas as a result. But unfortunately, that didn't happen. Now, here's the problem. Some scientists think that maybe the water they added back then actually destroyed those tiny Martian critters. Poor microbes were just hanging out and suddenly got soaked by a bunch of weird liquid. Something like this wouldn't be very pleasant for the Earth microbes. They live inside rocks and they're sucking water from the air. Pouring water on them would result in a total disaster. So, of course, giving them nutrients after that wouldn't do anything. If you've just barely survived a water bath, you're probably not in the mood for a feast. Perhaps these Martian buddies might have something called hydrogen peroxide in their cells. It helps them live in an extreme environment. If that's true, it could explain all the results from the experiments. You see, the instruments heated up the samples, so if there was hydrogen peroxide, it would have gone boom, wiping off the little guys and turning their cozy homes instantly. Imagine how ridiculous it would be if it turns out that we accidentally destroyed the only signs of life on Mars. Ideally, we need a new mission to Mars to test this theory. Let's hope it's not true. In any case, the journey isn't over. There are more missions planned for Mars, and humans might even visit this planet someday. The next mission is the Mars Sample Return. It's a super cool teamwork project between NASA and ESA. They're teaming up to bring back souvenirs from Mars, collected by NASA's trusty Mars Perseverance rover. There's going to be a whole bunch of spaceships. They'll work together to bring these precious Mars samples back. The samples are planned to arrive on Earth in the early to mid-2030s. And the fun doesn't stop at Mars. Our Mars missions are a warm-up for an even bigger adventure, exploring icy moons around Saturn and Jupiter. These moons have hidden oceans beneath their icy surfaces, and who knows what kinds of space secrets they're hiding. But whether it's Mars, icy moons, or beyond, our quest to find extraterrestrial life continues. In addition, we are slowly starting to find more and more organic materials on Mars, and maybe one day we'll finally find some microbes in our solar system. Let's hope for it and stay tuned.
Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation, phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus'
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's Cosmic Dust Analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus,
it was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the Moon's surface. It became clear that there was a global ocean between the Moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules, too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus,
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contained phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus,
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus,
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that.
Ah, well-deserved vacay, finally. This time you're off to see something new. It's an ocean on one of the Uranus's moons. Alright, just kidding. This destination is not a vacation spot yet. But yeah, there are definitely some impressive oceans out there. Hey, don't say you thought oceans can only be found on Earth. But before diving into Uranus Moon's oceans, let's talk about Uranus itself first. The 7th planet from the Sun, and the coolest cat in the solar system. It's got 27 moons, and 4 of them might technically have oceans. That's more than most people have, friends. All these moons are like Uranus's mini-me's. They tilt at the same crazy angle as their parent planet, 98 degrees to be exact. And Uranus is so unique that it orbits the Sun on its side. That means its equator is almost at a right angle to its orbit. Talk about rebellious. But why is Uranus like this? Well, some astronomers reckon it's because it got knocked on its side by a massive collision with another planet. And that impact might have actually created Uranus's moons. Fun fact, those moons have pretty particular names. Instead of mythical figures, most of them are named after Shakespearean characters. I mean, who needs Zeus when you've got Juliet and Desdemona? Discovering these moons isn't easy. They're super dark and located billions of miles away from the Sun. It's like trying to find a needle in a haystack, except the needle is smaller than your pinky finger. These 27 satellites are divided into 3 groups: 13 inner moons, 5 major moons, and 9 irregular moons. The irregular ones are rebels with retrograde orbits, while the others are prograde and go with the flow of Uranus. The big boys are Miranda, Ariel, Umbriel, Titania, and Oberon, and they're all in Uranus's equatorial plane and are big enough to be round. They've got craters and canyons and cliffs. Oh my. These moons also formed from a giant impact that tilted Uranus on its axis. That's why they're all tilted too. And because of that tilt, they have crazy seasonal cycles just like Uranus itself. But we haven't found all of Uranus's moons yet. The little irregular ones are sneaky and hard to detect, so who knows how many more there could be. But let's talk about the really cool stuff, what these moons are made of. We're not entirely sure, but we think they're made of rock and ice. Miranda is the most icy one, while the inner moons are probably just dusty. And the ones beyond Oberon's orbit, they're likely captured asteroids that could be rocky, or icy, or who knows what. But here's what really sets Uranus's moons apart. They're all tilted together with Uranus. That's wild. Exploring these moons could teach us so much about how ocean worlds form and stay active. Titania is the biggest moon of Uranus, but it's still less than half the size of Earth's moon with a diameter of about 1,000 miles. It's also the 8th heaviest moon in the whole solar system. They named it after the fairy queen in A Midsummer Night's Dream. Titania's color is gray, and it has some shiny patches that scientists think are frost. It's made up of a mix of ice and rock, just like all the other moons close to Uranus. Oberon is the next biggest moon of Uranus, named after the fairy king in Shakespeare's play. It's almost the same size as Titania, and also has a half-ice/half-rock composition. But Oberon's surface is way more cratered than the other Uranian moons. Umbriel and Ariel are the third and fourth largest moons of Uranus, with diameters of 726 miles and 718 miles respectively. Umbriel is named after a bad spirit in an old poem, and it's the darkest of all Uranus's big moons. It only reflects 16% of the light that hits it. Scientists don't know why it's so dark, but they think a bright ring around a crater might be caused by frost deposits. Ariel is the brightest of all Uranus's big moons, and it reflects over a third of the light that hits it. It's named after characters in both Pope's poem and Shakespeare's play. Ariel looks like the youngest moon because it only has a few small craters from recent collisions. Miranda is the smallest of all these big moons with a diameter of about 292 miles. NASA says it looks like it's made up of parts from different bodies, like a Frankenstein's monster. Miranda has three big features called coronae that are unique to it. They're lightly cratered with ridges and valleys, and they're separated from older and more heavily cratered parts of Miranda by sharp boundaries. It also has giant canyons that are up to 12 times deeper than the Grand Canyon. Scientists don't know why Miranda has such different features, but one theory is that it got smashed apart by a huge collision and then put back together all wonky. All these big Uranian moons are stuck facing Uranus all the time, just like Earth's moon. Uranus has got some seriously dope features, but the ring system is where it's at. And get this, the ice giant's moons actually have a hand in shaping those rings. Uranus has 13 inner moons and 13 faint rings, and they're all connected like one big cosmic family. Cordelia and Ophelia are like the guardians of the outermost ring, Epsilon. These two shepherd moons keep all the particles together, with Cordelia being the closest to Uranus's surface. But here's the kicker. There are at least 8 other tiny satellites hanging around in that area, making things super crowded. NASA is still scratching their heads trying to figure out how they don't all crash into each other. The inner moons are half ice and half rock, but we don't know much about the outer ones. NASA thinks they might just be asteroids that got caught up in Uranus's gravitational pull. Either way, Uranus and its moon squad are definitely out of this world. Apparently, Uranus's moons might have salty oceans hiding under their frozen surfaces, and the farthest ones from Uranus, Titania, and Oberon could have oceans that are 30 miles deep. That's deeper than the Mariana Trench, 7 miles. But even Ariel and Umbriel might have oceans around 19 miles deep. NASA used some fancy computer modeling and revisited data from their Voyager 2 spacecraft, launched way back in 1977, to figure out the makeup and structure of these moons. They found that Titania is huge enough to keep its internal heat and prevent its ocean from freezing. But get this, the other moons might have a chance at having warm oceans too. The researchers discovered potential sources of heat in the moon's rocky mantles that could release hot liquid and keep the oceans warm. And guess what? The oceans might even be warm enough to theoretically support life. The study also found that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. Now you might be thinking, how can these icy moons have liquid water? Well, turns out their internal heat and some chemicals could make it happen. For example, a study revealed that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as an antifreeze, and salts in the water could also help maintain the ocean's temperature. And if these moons really do have oceans, that means there could be other ocean worlds in our solar system and beyond. But don't get too excited. These oceans are pretty salty. About 150 grams of salt for every liter of water. That may not be saltier than Utah's Great Salt Lake, but still. As for Uranus's 5th biggest moon, Miranda, welp, it might have had an ocean at some point, but it probably froze over pretty quickly. Poor little guy. Anyway, NASA is thinking about sending a mission to Uranus to learn more about these icy giants and their moons. They're calling it the Uranus Orbiter and Probe, UOP. Sounds like a party to me. So yeah, technically there might be not 4 but even 5 oceans. but there's still much to learn and explore.